next one is the timers, which are peripheral, that is external to the ARM Cortex M4. Right? We will see how to program both the system timer as well as the external timers also. Okay, first, let us come to the system timer. Okay, so system timer is the SysTick timer. It is called as the SysTick timer. So here, this SysTick timer is nothing but, okay, this SysTick timer mainly it is used to do a periodic to generate a periodic timing interval, right? For example, you can take I want to read a sensor every 200 milliseconds, or I want the operating system to schedule the tasks at every 5 milliseconds, like that. So if you want to do some periodic events, then you can go for the system timer, right? So system timer can be used. Okay, just give me a minute, 1 minute. Okay, so what is happening there? So everyone, uh, okay, you are in the office. Okay, good. Yeah, but why are you all like at the table, boss table, or at the trans table? I can see, right? Wi-Fi is okay. If you are having that problem, I can give you some pre-read. You can go through that pre-read, right? And try to work on the timers, and we can connect tomorrow. That's not a problem. Will that do good? You- Yeah. So, yeah, because I can see everyone, you are grouping together at one table, right? You are having fun together at office. Yeah. Just give me a minute, 1 minute. Okay, I'll give you a pre-read on STM32 timers. You can go through that and come back. You can work on the STM SysTick timer also. Okay. Just give me a minute. Yeah, I'll share you the program for SysTick timer also. Give me a minute. sharing you the program here for the SysTick timer. Okay, this is for the SysTick timer program. Okay, I will I'm sharing my screen. Is my screen visible? This is for without interrupt, that is using the polling method. When actually the timer overflows, uh, those conditions are taken care here. And this is with the handler. Okay, so with the interrupter. Okay, I'll tell you both the things what to do. I'm just putting both the programs here on the chat. You can copy it. So what you need to do is here I'll open the Cortex M4 manual. I had closed that earlier, so I'll just open that quickly. Okay, what you need to do is go to the Cortex M4 manual and go to the peripherals. Here you have the SysTick timer. You need to define the addresses of these different registers, right? You can include these things, right? That is STM4XX also. But I want you to do that using the register definitions, right? These are the addresses of the different registers. This also I will put in the chat. Okay, so that you can copy it. Okay, so you can rewrite the program using these register addresses. Work on this. You have to include when you are toggling the LEDs, include the LEDs which is connected to the whatever 12th pin or like that, depending on your 407 controller. Okay. So these lines you need to change. This is for STM446 array. You need to toggle the LED for 407 microcontroller. Change these things, but these things will not change. Okay, and to calculate the load value or what is this value, all those things, I will share you the program, or I will share you the okay. So this is our SysTick timer. Just 2 minutes, I will give you the introduction. It contains two registers. One is the SysTick current value register and the reload value register. This is the current value register, which does the counting operation. Reload value register will hold the counter, right? It is a 24-bit down counter. Whatever value you load in the reload value register, when you start the SysTick timer, that value will be copied to the current value register, and you are providing the clock pulse here. For every clock pulse, the current value register contents will be decremented by 1 till it reaches the value of 0. When just like for example, if you have loaded 9 here, for every clock pulse, it will decrement to 8, 7, 6 like that. Once it reaches 0, this is called as the timer overflow. And when it reaches the value of 0, the count flag will become equal to 1. Right? When the count flag becomes equal to 1, it means that SysTick timer has reached 0. Right? So these are the two important registers. Other than that, it contains the control register, where it contains to start the SysTick timer, you are going to give this as equal to 1. And there is a clock source here, which can be internal or external clock source. If you are choosing internal clock source, this has to be equal to 1. And if you want the interrupt to be generated, then you have to make this D1 bit as equal to 1. Next, we have the count flag here. Whenever the SysTick timer reaches 0, the 16th bit will become equal to 1. By monitoring the 16th bit of this register, you can see when the timer has reached 0. At that particular point of time, you can read a sensor value, toggle the LED, or whatever operation is to be done, that can be done when the count flag becomes equal to 1. You are monitoring this 16th bit, right? Now, to calculate the count for the particular delay. So, if you have loaded the count as 9, so it has to count from decrement from 987 upon receiving each clock pulse, right? So till it reaches the value 0, the time it takes to count down from 9 to 0, that will produces the delay, right? For each clock pulse, it will be decremented like this, 9, 8, 7, 6, 5, like that. So one clock pulse is required for one decrement, right? So if you know what is the period of the clock pulse, it takes that much amount of time to count down once, right? So it has to count down from 9 to 0, means 9 clock pulses are required, right? So it is 9 into whatever is the time duration for one clock pulse. Here we have used 8 megahertz as the clock frequency. 1 by 8 megahertz, you will get 0.125 microseconds. 9 into 0.125 microseconds is 1.125 microseconds. That is the time that is required to count from 9 to 0 using the system clock of 8 megahertz, right? So in general, this is the formula. Delay, what you require is equal to n divided by what is the system clock frequency, right? So this also I'll share it in the chat. Okay. You can calculate the delay in this way, right? Whatever delay you want, D is equal to n divided by system clock. What you can do is take the system clock frequency as 16 megahertz. Okay, 16 megahertz. And you can calculate for different delay. What is the n value for different delays? Okay, for delay of maybe first 500 milliseconds, right? And you can calculate for a delay of 1 second, what is the n value. So like that, you can calculate the delay for different time intervals, right? And you can instead of whatever you were doing, right, you are producing delay using for loop. Instead of that, you can have the specific delay here. So you should toggle the LED exactly at 500 milliseconds. You should toggle the LED at 1 second, or delay of what is that, some 250 milliseconds, like that, right? So you can work on the a program of like each LED, whatever LED is present, 4